All right, we're getting really, really close to the end of our algebra unit. Okay, we've got one more lesson on factorization for you guys. Previously, we factorized out numbers. Today, we're going to be factorizing numbers and variables. So we're going to be getting letters and numbers out of our work. So to take it to the next level today, let's just remember what's come before us. We were given two terms, and we were asked to factorize them down. So we kind of asked you to look at the numbers in each one, so a 4, a 12, and decide what is the best, biggest common factor that goes into them both, like the biggest number that times or divides into 4 and 12 evenly. So in this case, the best number going into 4 and 12 would be 4 itself. 4 goes into 4 and 4 goes into 12, and we've got to divide that 4 out. Right, so 4x divided by 4 is x, and there's a minus there and there's a 3, because I went 12 divided by 4. We also showed you what to do if both of your terms were negative. You should put the negative out the front. Look at your numbers, 3 and 9. The number 3 is the best one that goes into 3 and 9 evenly, and then divide that out, right? So I'd have an x here and a plus, because I got rid of the minus, I factorized it out, and a 3. Right, so that's where we're at so far. Today we're going to factorize a bit more out of the terms that we're given. All right, so essentially what's going on today with these questions is you'll be given two terms again. They might have numbers in common, right? So you should be trained to look for numbers that go evenly into both, but there's going to be a bit more than that. Okay, so if I look at x squared and 3x, there's no number at the front of x squared, so we're not really going to be factorizing at a number. We might just for a second think about what these look like in their expanded forms. All right, so this isn't working out you need to show, but it's just a thought process that might help you, right? Knowing that x squared is x times x, right? That's the long way of writing x squared. And 3x, another way of writing that, is 3 times x. So if I'm looking at kind of this pair of factors, right, the things that multiply to make x squared and the things that multiply to make 3x, all we're looking for is what they have in common. And you'll see what they both have in common is they've both got a letter x in them. All right, so because they've got a letter in common or a variable in common, we can actually factorize that out as well. All right, so what we're just looking for today is numbers and letters that our terms have in common. So the thing in common here is x. All right, I open up my brackets because I'm going to be dividing by x or getting rid of it. Okay, you can just view it as whatever letter or whatever variable I'm factorizing is going to disappear, right, from each of my terms. So if I start with x squared, which is 2 lots of x, and I get rid of one of them, I've still got one left. And if I started with a 3x, but I divide the x away, well, then I've just got 3. All right, so this is what happens when you try and factorize these two terms down, right? They didn't have any numbers, but x is in them both. Right, this one has a couple of x's, this one has one. So because they've both got an x, I can factorize x out, and I'm just left with whatever each term has when I actually get rid of that x. So this turned into that, and this turned into that, because they each have x less than they had before. So we'll then ask you to look at a combination of letters and numbers. We've got a 26 and a 39 out the front. Close, careful inspection of these two numbers tells me that they're 13 apart from each other. So maybe the number 13 is something they have in common, right? 13 does go into 26 and 13 does go into 39, right? Hopefully we don't use big numbers in our questions today, like 13. So I might just break this down a little bit, right? So 26x squared, right? So the number that goes with 13 would be 2. Right, 13 times 2 is 26, and x squared is again writing x times x. So I'm not going to make you write down all this expanded form stuff. I'm just trying to think about kind of the building blocks that would make a 26x squared, some of the things that would go evenly into it. If I did the same thing with 39x, we know we're working with the number 13 because we've thought about a number that goes evenly in. 13 pairs up with 3 because 13 times 3 is 39, and then there's an x there as well. So the reason I've broken this down for you is to try and show you that we're looking for everything that's in common between these two terms. So they both have the number 13 in common, but that's not all they have in common. They both have the letter x in common as well. Right? This one has a couple of x's, but this one has one. So we can say they both have a 13, they both have an x. So they both have 13x in common. That's something that goes in evenly in terms of its number and its letter. So that means we're going to be whacking a big 13x out the front. And then we just have to think about what's left over when I divide each thing by 13x. So I'm going to divide this by 13x first. 26 divided by 13 makes 2. and there were a couple of x's in this one. There was x squared, and I got rid of one of them, so I've still got an x left over, right? It's these two things here, right? The ones I didn't circle. And 39x, or I better put a minus, right? Because it was negative. 39 divided by the 13 is 3, and there was an x, but I factorized it out, so there isn't an x there anymore. Right, we can check that we've done this right by timesing that back in if we want. That would make 26x squared. That would make 39x. We've done it right. Okay, so essentially your goal is to find whatever's in common, right? A number, a letter, and then get it out of there, divide it out, and see what you're left with. Okay, so the more that we throw at you, the more in terms of numbers and letters and other letters, the more you've just got to be careful and take it kind of one thing at a time and be just really meticulous. Even when it starts to get longer and we put multiple variables into each term, you've just got to try and just find things that are in common, basically across all your letters, starting with your number though. So I've written it differently this time. We'll just look for things that are in common. I mean, you can break it down like we did before, but let's just go from left to right and try and look at what they both have in them between this and that. So we should start by finding a number that they both have in common, a number that goes into 35 or 21. You could think about your times tables. Is 35 and 21, do they appear in the same times table? And they're in the 7 times tables, right? This is 5 sevens, this is 3 sevens, so 7 will be our number. Let's look at what they both have in common in terms of their letters. So this one has kind of 3 lots of x, x times x times x. This one has just 1. Okay, so we can only write down what they have in common, what they both have. So they both have at least 1x, right? This one has more, but they both have 1 at the very least. And same thing with y. This one has a whole bunch of y's, or it's y times y times y times y, right? So there are 4 y's being multiplied as factors. It's y to the power of 4, but this one just has 1. So the smallest amount between either, right? The smallest amount they both have is 1. Right? That means that my factor that I'm going to factorize is 7xy, because that's what they both have. And then we're going to try and get 7 and x and y out of both terms. So when I do that, we'll start here. We're going to divide the 35 by 7. So we put a 5. Right, 7 and 5 make 35. Then I have to get rid of one lot of x and one lot of y from each one. Right, so with the first one, when I get rid of one lot of x, I've still got x squared. Right, I started with 3, I factorized 1 out, now I've got x squared, I've still got 2. And I don't need to put a y here, because I just factorized one lot of y out. We move on to the second term now. We'll put the plus in between, and let's divide the 21xy to the power of 4 by 7xy. So 21 divided by 7 makes 3. Okay, and I divide the x out, so there's no x there anymore, because there was just 1, and I need to factorize out 1. And then think about how many y's I'd still have. After factorizing this, I had 4. I get rid of 1. So now I've got 3, right? So even when they start to get long and convoluted, just take it one thing at a time. Start by finding a common number. See if there's any letters in common as well, and just get them out of there and break each of your terms down bit by bit, and you'll get close to having the right answer, hopefully.